and welcome back. This is another kernel story, another attempt at power-aware scheduling. Similar to the previous patch, this is, but more so, this is not really the final patch. This is very much a statistics patch to log some data, and it's all about choosing performance and scheduling of processes on a system based around the idea of minimising power so that you can maximise battery length. The scheduling, at least in the Linux kernel, and I'm sure it's the same everywhere else, it is the bike shed. It gets changed and added and swapped and modularised and pluginized all the time. And I think this is like the third attempt at this that I can remember reading about. But, you know, it's one of those things, like we have read a few stories previously where don't actually worry about the power use of processes, just schedule them to get the jobs done as quickly as possible, and then magically out the other side, when you do all the jobs as quickly as possible, you'll use the least power overall.
Well, no, I mean that doesn't work. Doesn't work because as the story mentions, it was a non-issue on your typical core laptop, which has lots of processors on a single die that all are all identical. Where it becomes a hassle is where you have different CPUs on the same die that can include different speed and power mixes. ARM big little actually breaks your assumption. So ARM big little, the ARM 7s, I believe, execute like a dog. So very, very slow, but they also chew significantly less power, even though they take far longer time to do it. So you've got this problem. You've got to be able to predict how long this process is going to take to achieve it, because if it takes too long, the system's going to be perceived as slow. But if you put it on a fast CPU, it's going to take far more power. He's just putting in a framework which says, yes?
Do you see a return to the mainframe days of scheduling the jobs by specifying this is a user-intensive task, requires immediate servicing, this is a background task, get it done this hour?
Mark has just asked whether we see a return to the... Well, basically a process must declare how long and how fast it is going to execute. So I'm prepared to execute in a background mode, which can take forever but use. Or I'm interactive. I need to get done now. I interact quickly, or the user experience is compromised. The answer to that is they probably do this now. Android, for example, already knows this. Foreground task, its UI thread in particular has to execute immediately. And like on Android, if you try and do something that could take a significant amount of time on the main thread, it will throw an exception. So if you try to do network I/O on the main thread, it's not, it's going to slow it down. It actually throws an exception, your app dies. So you know, on these devices that have display one window and it occupies the entire screen, there is no doubt about what process needs the intensive process speed to make it look crisp. I don't think you'll have to declare it. I think they'll be able to infer it.
The problem though is you can take a stab at what the program's going to do in the next 10 seconds by having a look at what it's done in the previous 10 seconds, but there are a lot of programs that are very bursty, where they'll sit there and do little bits, and then all of a sudden a timer will tick over and they have to do a lot of work, and then all of a sudden they'll need a lot of CPU power. And that's a fundamental problem that all scheduling systems have to deal with.
True, but Android has background tasks, so like if you have a download manager that polls every hour, but it's a background task. You don't give a rat's how long it takes to pull it down. if you're the foreground task and a timer has just gone off, so you want to, I don't know, implement Blink in HTML, then it's fairly important that you react immediately, otherwise you're going to look sluggish. And they can tell that because you're the foreground task, you know. It's your timer, you're waking up, it's the foreground task. Presumably the task that's displaying something wants it done now. But there are a lot of interrupts that go off, and that, like on mine, I have chat clients running in the background. Google spies on me innumerable ways in the background, transits my location, figures out whether I'm walking or riding a push bike, where I last parked my car. This all happens in the background, and I didn't ask them to do this, and I don't particularly give a rat's how long it takes, and they know this, so they put it on big little.
Part of, I mean, certainly a lot of this stuff is aimed at the embedded market, but we are heading into a space where we're actually starting to care how much power our servers use, and you know, we don't have systems on racks just yet, but we will be seeing those in the not too distant future.
You're absolutely right, and I possibly misinterpreted Mark's question earlier, because I was thinking in terms of Android and batteries, and I'm actually looking at, in the not too distant future, replacing my server with something that saves me a couple of $100 a year. Once it gets to the point that it saves me more money than it costs me for the motherboard, I'm going to replace the motherboard.
And there's a fundamental difference when you're running on mains versus when you're running on battery, because you know, when you're running on battery, you want to lessen the overall peak load of the battery. When you're running on mains, it's just dollars and cents.
Yeah, well, in that case, all the things I talked about knowing which is the foreground processor are utterly friggin' irrelevant. So,
yeah.
And in which case, Mark saying it's got to be done now makes a lot more sense. Your other comment about the fights that break over the schedule are actually accurate, but I think more reflect the personalities of the developers involved. There's another scheduling problem, which is equally difficult to solve in Linux. In fact, I suspect harder, which is the disk I/O scheduling problem. You know, which page are we meant to read or write? Or
I remember there was an LCA talk a few years ago where some guys sat down and actually ran the numbers on their database loads, and they because all these schedulers are pickable at boot time, and they had the best performance by picking the no-op IO scheduler.
Well, this is the point, you see. When I was talking about the personality of the developers, it has been proposed repeatedly that the scheduling problem about letting us choose the appropriate scheduler should be handled the same way the disk I/O was, and have a pluggable interface, and we could choose among many competing interfaces. And the guy who controls the scheduling, Ingo, has every opportunity said, no, you must use mine. Mine is the only one, and given a whole pile of reasons.
Well, not having to argue about 100 different plugins seems like a reasonable response to that.
Well, I mean, do you argue with anyone about which plugin you're going to choose?
Well, if it's going to end up in, well, if you provide a plugin module, you're going to have to allow a few people to get their plugins into the kernel, and then
that's exactly what's happened with Disco. Has it caused a problem? You got CFQ, you've got the
is it the stepped one?
The step one. There's quite a few, and they work better for different loads. And you know, you go around the Linux sites and you can see which ones work best for which loads, and you choose appropriately. I don't see it's caused a problem, and it certainly took a lot of heat out of we are going to choose one and only one, and it shall be the best one for everyone, as opposed to you've got all these interfaces, you make the decision. And it encourages experimentation. Like, so this guy could have done his thing without having to roll Ingo, which about 0 chance of doing that.
Yep. Because, I mean, particularly in the scheduling one, there was that quite famous one where an outsider came into the
An
Linux
Australian.
kernel.
An
Yeah,
Australian who was not a programmer or anything else, and actually forced Ingo to change
yeah,
to something that was actually more reasonable.
yeah. And I mean, he was just trying to improve his user experience, really.
Yes. Unbelievable guy who had no, I don't know, forgotten what his background was, coal shuffler or something or other, and cut into the Linux kernel, rewrote the scheduler and produced something that produced better numbers than Ingo. So Ingo's response wasn't to incorporate his scheduler, was to rewrite his scheduler so that it incorporated some of the ideas. And then diss this guy for being an idiot. Anyway, such is kernel life.
Well, you know you've made it when you've been dissed by a kernel guy, right? And so, I mean, this is not a scheduling patch. This is very much a statistics gathering patch. So any numbers that it gives at this point in time are very early, but he does talk about power savings from 3 to 50% depending on the workload on a big little system.
Which would be extraordinary because the kernel's very good at it at the moment.
Yeah, yeah.
The major problem is programmers who want to poll USB devices.
Yes. Well, I wouldn't be polling the USB devices, I'd be polling their resistance. Slightly different thing. There is also an approximate quadrupling of the time taken to switch tasks, which
Holy jeez, you couldn't justify that.
which might not be a good thing on an interactive device, shall we say?
No, it's not that. It's the short-lived tasks. Task switching does actually take a significant amount of CPU power as it is. Anyway, all right, I missed that bit.
Yeah, well, you know, the problem with these articles is that, I mean, and this is not even the final patch, but there are so many numbers that they're throwing at you, and it's not like all of these patches, you have to talk about them in respect to a particular workload, a particular hardware, particular power source, and, you know, even if at the end of the day they give you back like a simple graph with numbers, there's still so much context around that.
Yeah, well, anyway, it was an interesting article with Jonathan, who normally writes...
Oh, was that Jake or was that Jonathan? Yeah, it was Jonathan, yep. Sorry.
Who hopefully will still be with us in a few years.
Thanks very much.